Hello, welcome back to the Leukopak Lady. I was at a conference recently where I talked with an academic scientist who had no concept of how the leukapheresis process worked. And this is totally understandable because leukapheresis is not something that's typically taught in research and scientific training. He asked me a bunch of questions about how the cells were collected and concentrated and how the donor's blood was cleaned out of the instrument in between collections. This gave me the idea to do a leukapheresis tutorial for people like him, and frankly like myself, when I was just getting started in this field. I've never had any formal training in the collection process, but I've been involved in collections as a program leader and donor, and I've asked a lot of questions and I've studied the process on my own. So in complete Leukopak Lady style, let me explain the leukapheresis process as simply as possible, as I was able to explain to my fellow conference attendee recently. So let's start with the centrifugation of blood. Traditionally, a tube of whole blood, which is a mix of red blood cells, white blood cells, platelets, plasma, and proteins, becomes fractionated by the centrifugation process, with red blood cells on the bottom, plasma on the top, and the white blood cells between those layers. If you take a closer look at the white blood cell layer, there is further fractionation based on density. The heaviest particles are on the bottom and the lightest are on top. Red blood cells are the heaviest because they contain iron molecules. Granulocytes migrate on top of the red cell layer, followed by monocytes, the large mononuclear cells. Lymphocytes, the smaller mononuclear cells, migrate just above the monocytes. And since NK cells are large granular lymphocytes, they migrate somewhere between the monocytes and the B and T cells. Platelets are fragments of cells, so they migrate above the lymphocytes. Plasma, filled with proteins, is the top layer. This principle is the same in leukapheresis, but the system is designed to remove only certain cells from the white blood cell layer. So let's dive into this. The leukapheresis instrument has some notable features: the collection kit, collection bags, centrifuge, and control panel. The collection kit and collection bags are attached through a sophisticated set of tubes and plastic reservoirs. When attached to the donor, the kit creates a completely closed system. Blood is pumped out of a vein in one arm of the donor, circulates through the kit, and returns to the donor through an IV in the other arm, all without touching any part of the instrument itself. This plastic reservoir snaps onto the front of the instrument, and the tubing wedges into peristaltic pumps. These pumps are responsible for moving the blood and fluids through the kit. This one moves the blood into the centrifuge. Here's an above view showing that it's not like a typical centrifuge. It doesn't have rotors or buckets to hold tubes. Part of the collection kit is a thin band that fits into the arced groove of the centrifuge and fills with blood. As the centrifuge spins, the blood inside the thin band is separated into layers, just like in a typical centrifuge tube. The centrifuge spins at a constant speed, keeping the layers of the different white blood cells in predictable locations inside that band. Here's a representation of the inside of that band, and where each cell type falls. The sweet spot is right where the monocytes and lymphocytes are. Here's a view of the control panel showing where the cells are being siphoned from, halfway through the depth of the layer. One of the ways apheresis nurses monitor which cells are being pulled from the white blood cell layer is by checking the color of the tubing leading from the centrifuge into the collection bag. The more red it is, the more red blood cells are present, and the more clear it is, the more platelets and plasma, but fewer PBMCs are present. Adjustments to how deep into the layer cells are siphoned from takes place throughout the collection process. If done correctly, granulocytes, red cells, and platelets are avoided, and only the PBMCs end up in the bag. A good quality leukapheresis product should contain less than 10% granulocytes and as few red blood cells and platelets as possible. Therefore, it takes skill to do this right. So let's look at the process from a simple two-dimensional view. Blood is pulled out of the donor into the collection kit and mixed with anticoagulant to prevent clotting. The blood then enters the centrifuge, where the PBMCs are siphoned from the white blood cell layer into the collection bag, and everything else, which is the red cells, granulocytes, platelets, and plasma, is mixed with saline and returned to the donor. The blood and saline are warmed before re-entering the donor through their IV. In many cases, the donor experiences side effects of the anticoagulant, which can cause mild or moderate hypocalcemia. To mitigate this, donors are given a calcium supplement either orally or through their IV. The use of a blood warmer and calcium supplementation are important for donor stewardship. They're not required for the process, but since the collection typically takes 3 to 5 hours, these interventions help keep the donor warm and comfortable and increases the likelihood that they will return for future collections. So I know this was extremely oversimplified, but hopefully it was helpful for those of you who find the concept of leukapheresis to be completely foreign. I'll see you back here next week.